So my name is Elena Volkova, and now I will show you the new experimental feature that we have added in this release related to generating code preview for preview and troubleshooting purposes. So the main request for this feature was to be able to compare generated code. And there are several use cases where this can be useful. For example, when you're implementing something new and you want to preview what will happen to your generated code, or you have some previous version in Git, for example, and you want to compare what were the changes related to the generated code. So now you have a new command, and currently it is marked as experimental. It is called generate code preview. You can notice that there is also a keyboard shortcut to make it fast. It will generate code for the selected model element into a special location. There will be a special project, and this is the default name that we suggest to use for it. So I will just press OK. And now I have a code preview generated for my capsule that I have selected. So this is the special project, and there are only two files generated, the header file and CPP file for your capsule. And the header file will be automatically opened in the textual editor, while if you want to see the CPP file, you can just go here, navigate, and double click and open the CPP file as well. While you have this file opened, you can go back to your model element and do some experiments with it. So, for example, now I want my capsule to become abstract, and I want to see what will be how the code will look like now. So I will now use the keyboard shortcut Alt-Shift-E, and the code is immediately regenerated. You see it's working quite fast because when you are selecting a specific model element, it will load only this model element, the model file containing this model element, and if it references any other types, for example, it will load only one step. It will only one step load, only the types that it references. So it will not be loading the whole sources closure for this model element, and that's why this operation works faster compared to the normal transform of everything that you have in the model. And now you see immediately what are the changes. So we see that this, we have now this equals 0 appears to the RTist behavior function. And also this special project, if you are using the same output location, so here you can, in this preview location, you can specify different folders here. But if you are reusing the same folder and the same project, then a special files with this tilde at the end will be maintained, and they will contain the previous version of your file. So now, if I want to be more specific in what were the changes, then I just go here, select the files, and I can use an Eclipse built-in compare, and I will see what are the differences in the header file. Basically, I see that this override equals 0 appeared, and actually this array RTG parent state, it's not available anymore, so maybe I can swap the panels, so the tilde version will be on the left and the normal version will be on the right. So as soon as you have stopped this troubleshooting, you can delete everything, and you are free, because this is a separate location on the disk in your workspace, and you just delete everything, all the files that that were generated. And also this compared review, unfortunately, while you're deleting the files, this compare view is not removed, so you have to close it manually. Another useful thing that you can do with this code preview is when you are creating something new and you don't have any TCGS, so you have just started to create any new classes, new model elements, and you want to get a fast preview of what will be in the generated code. Like for this, for example, enumeration, I want to see what will be the code. I press Alt-Shift-E, and now since I have removed this code preview, it will ask again for the first time what is the location where you want to get it. So I will use this default location. And now I get the version of my file, and I can, for example, do some experiments. For example, this scoped. If you don't know what is this checkbox, what does it mean, you can try. And now I press on Alt-Shift-E, and now maybe you have noticed that this class appeared here in the preview file, but you can also go to this code preview and compare these versions, and you will see that the difference is in this class that appeared. You may keep this compare view opened and continue doing some changes, and they will be immediately updated in this compare view. So, for example, now I remove this scoped, and now in this case it's very useful to use this keyboard shortcut. So you don't need to go and find this element. As soon as it is selected in your Project Explorer, you can use Alt-Shift-E, and the code will be generated for your selected element. And I see that now this class has gone. So what else? I can change the type. Now I want to use int. But here you should be careful because now, while I'm in this text field, the model is not yet updated. So here we don't see the star marker that the model was updated. And you need to click somewhere outside of this text field in order to get the model update. So now you see this star, so your model is updated. And as soon as you run this code preview, so now I do that, Alt-Shift-E with the keyboard shortcut, the model is saved automatically because this is the operation performed by model compiler, and it is operating as a server, and it requires that all changes are saved on disk. So as soon as you use this operation, your change will be saved automatically. And now in this preview, you see that the only change that we now got is the change of the type for this enumeration. So how it is working, this code preview for a single model element, even if you don't have any TCGS. So how this is possible? So we're using, we're generating this TCGS on the fly, and there are some, of course, there will be differences, minor differences in how your generated code look like compared to when you do a normal transformation. I can now show you what will be the difference. For this enumeration, I don't have a TCGS, but for my capsule, I think I have a TCGS. So now I will generate. Now I have this element selected. And by the way, you can select several elements, and you can generate code for several elements at a time. So now I selected 3, and I will get 3 elements generate into code preview. Yes, now you see, but when you're using more than one model element, the header file will not be opened because you have selected several model elements, so it will be too much to open all the files for all these elements. And now I think I have in some other, yes, here I have the result, the code generated by the normal transform. And now if I compare, for example, for this capsule blue, I can show you what will be the difference with the normal generated code. So mainly there are, the main difference is in this unit name. This unit name, it corresponds to the TCGS that you have selected, and since we are not using a TCGS for code generation, when you are generating it for an individual model element, then we don't know what was the unit name defined in TCGS. And that's why we're using this special file, and actually it is also generated, but since its name starts from dot, then by default it's hidden from the view, so you don't see it here. But actually, if you check on this, you will see that we also are generating this dot unit name .h. So that is very small and contains simple standard include to target RTS, but it doesn't contain any common preface or other things that come from TCGS, because in this case we don't use TCGS. Also, if some of the elements like this capsule library blue, if they come from the different TCGS, which defines a subfolder where the sources are generated, then we also don't know that. And that's why the include will be generated without any subfolders. And also in the TCGS, there are some settings for the code generation which will not be considered, like this common style. So we will be using a default common style by default while generating this code preview. And some of the options like this generate fully qualified state names, we will also be taking the default setting. But the main purpose of these generated files are code comparison and code troubleshooting. So for comparison purposes, it's to see the differences. It's not so critical to get some of the options taken by default, and the unit name will not be like this, but it will be that special dot unit name .h special include. So another interesting option is if you have your projects in Git, then you can compare different Git versions of your file. So we can now try to do that, and I will now delete this, and yes, and I will now also close this compare. Yeah, I have deleted. I have to close my compare editors, and also I think I did some changes. So I will now just remove the changes that I did. And I have a simple Git, local Git with just 2 commits to show you how we can compare versions from different commits. So I go back, and comparing Git, you can do as well, compare different Git revisions for this individual model element if you are troubleshooting this capsule run blue. And now I think what we can do is first we can navigate to resource root. Then we can open this resource root in history, or maybe we can even simply we can go to this Git perspective, and we can see what were the commits. And I can now check out the previous version. Yes. And now I go back to my model, and I select my model element, and I generate code preview for this capsule. So I have one version of the file. And now I can go back to Git, and I check out this version. And now I go back to my model and go back to my model element, and I generate again. And now I see that both header file and CPP file were changed between the commits, and I can observe the differences using this standard compare. And I can see that first I was changing how the includes, the method for the includes, they are controlled by the dependencies defined in the model, and in the header file it seems it's it. And also I think in the CPP file I can compare what were the changes. Yes, so in the CPP file I see that this includes so in the previous version, they were in the CPP. Now I have seen that they appear now in the header file, and these external references are gone from the header file. And also I see two more changes here in the type descriptor. I see that before I used only one instance of a capsule part, and now I changed. And now I have from 0 and 55. I have 55 instances, and also this changed to optional. So this is what you can do with the individual model elements. But also the same option is available on the TCJS. And if you are using a TCJS for code generation of code preview, then you will get absolutely the same code as you would have got while running the transform. So, for example, I want now to use TCJS for code troubleshooting, and in order to find what is the TCJS, I can use this command, transform configuration references in the enclosing project. And I select a TCJS. Now it's this one. So this TCJS that I can use to generate code, and it will also include my model element and actually all other elements. So let's do it, and I will use the same command, generate code preview, and now I can specify a folder, like for example O1, because now I will get all generated code. So you see we have generated 90 files. So all the code was generated, and the folder structure is also kept. And we also are generating makefiles and CPP and header files. And in this command, you can select the scope, what you want to generate. So by default, we are generating everything, source code and makefiles. But if you are interested in troubleshooting only makefiles, for example, you can select this option. So, but now I have generated code in O1. I have generated all code, so all CPP and header files and all make files for the current TCJS and for all prerequisites. So all libraries are also here. Generate code for my library TCJS. And as an experiment, now I want to see what will be the difference if I will change the C++ code standard. So we have introduced this recently, support for C++11, and now I will use the old C++ standard in the preferences, and I will generate code. Now I need to explicitly to get this menu again. That's why I used context menu, because I want to specify a different folder for the whole bunch of my new generated code. Yes, now I have it, and now I can use structural compare, which is also available in Eclipse. And here I will see all files which are different. So if I click, double click on the files, then I see the difference between what was in folder 01, which was generated for the C++11, and folder 02 was generated for the old C++ standard. So here I see that now pointers were added, and if, for example, I will go here to capsule 1, I also can observe that override keyword, it is generated for C++11 standard, but it's not generated for the old standard. And so by clicking these files one by one, I can see all the changes in the generated code in all files using this structural compare. So the same you can do for your different Git revisions. So now I will delete this. And I can do the same, but use different Git commits for my generated code. So I will now close this compare editors. And now I will go to my Git. Yes, so I will check out previous version of files, and now it will make sense maybe to give some meaningful names to the folders. Maybe I can even use like this. I can use the first commit identifier, the first digits from my commit identifier, and I will generate code. Assume I want only to compare source code. I don't care about any changes in makefiles. So here I will use this commit identifier, and now I get all code generated for this commit. Only CPP and header files without makefiles. Yes, and now I go back. I check out this version. I forgot to copy. So I also want to copy the first digits from the commit identifier. Now I go here and I specify a new folder for my new generated code. And now, yes, I think I have it. And now I use the same structural compare to see the difference between two Git commits. So I click on these files, and I see that I was adding dependencies to this capsule 1 blue, and I was changing the type of dependencies. Here I see that cap attribute 01, it's not present anymore. So if I click on the header file, I see that I have removed an attribute. It's not generated anymore. And in capsule 3, I see that I have removed final. Here I can observe the header files. I see I was adding some of the common preface, which is now generated, but what was I just need to understand what was the previous version and what was the latest one, so I can maybe I need to swap panels, because so the previous version was this one. Yes, so if I go back and I see here that, yeah, probably I need to swap panels, because this is the previous version and this is the later version. Yes, and here I can also see that I was adding some pure virtual function into my parent class. And as well, I see that here in one of the libraries, I have some changes. I was adding dependencies and something also removing some attributes. So this is the way how you can compare generated code between two Git commits. And last that I wanted to discuss maybe and to tell that what is the difference between the code when we are generating this code using TCGS. So what is the difference in when we are doing this code preview compared to when we are doing the normal transform? So first of all, in the code preview, we are not initializing CDT projects. So when we are doing a normal transform, all of the target code, which is here, this target code, all of these are initialized as CDT projects. And after code generation, there is a indexer, CDT indexer, that is starting, and sometimes it's actually quite annoying, because for huge models it takes some time to index everything. So as a consequence, you will not see any, if you observe this code, if you hover over your elements, so you don't have any hints, because the indexing, CDT indexing is not done for this. So this can be considered as a plus or and as a minus as well. We are using a separate project in order to maintain the previous versions of files. So when you are generating in a normal way, you do a normal transform, then previous versions of files are deleted, and obsolete files, if, for example, you have removed something from the project, all obsolete files will be also removed from your target projects, and it makes it not possible to compare. So that's why we are maintaining and having a separate place for this code preview. This special name, but by the way, we are using this, maybe it's a bit ugly, but when you hover over here, you can easily see in the prefix that you have this code preview, and it is easily noticeable that this is this file, the CPP file, is something that you are now using for troubleshooting. Post-processing also is not performed when you are doing code preview, and problem markers are not generated. And also, while doing a normal transform, we are generating additional information for code sync. For code preview, we are not doing this. So if you will be updating any of the files of the USR code snippets from the code preview, then code sync will not be done. So this is only a number of CPP and header files with some different versions that you can compare and compare with each other. And later, after you have done your troubleshooting, you just remove it and continue with your normal work. So I think that's it about this. Yeah, so this is an experimental feature, and we are very willing that you try it and give us your feedback and comments about the usability. And yeah, and so on. So any questions?